joining us now for a keynote address on energy scarcity and critical minerals, a kinder, more capital-efficient path to scale. Please welcome Chief Executive Officer for Baruch Future Ventures, Tom Baruch.
Thank you, everybody. Nice to be here again. It's been 2 years, and it's just been fantastic to see how the organization has grown and during this period, and that somebody had the foresight to envision that at some day critical materials were going to be front and center. And Robbie, thank you for that. I've been thinking a lot about how we translate biology into industrial systems. When I was here 2 years ago, I gave a talk on capital scaling and exponentiality. These were the three critical path items that we assessed every time we look at an investment opportunity. And that has served us extremely well. Two of our companies, Fervo and Cobalt Metals, for example, have done extremely well with multidisciplinary approaches to solving problems. In biology, it's a little different than the way we think about Moore's Law. I talked a lot about Moore's Law last time, and I talked about how biology can scale through replication, the way semiconductors scaled through miniaturization. 2 years ago, this thesis was largely theoretical for most of the people in this industry. Yes, biology could scale exponentially. That was interesting. It was possibly true. And yeah, it probably was worth watching. Well, the last 2 years in linear time have been more like 10 to 100 years in exponential time. We've seen massive progress. Most importantly, design tools based on AI. That was a program that was pioneered by Google called AlphaFold. AlphaFold was initiated in 2015. By 2013, 2023, AlphaFold was still there and a few people were using it, but it was not being widely used. Well, in the past 2 years, we have at least 50 new companies that are involved in the application of AI to synthetic biology. And actually, we can start to distinguish between biology-enabled technologies that are actually capturing scaling economics, because that's the key. That was the key of capital scaling exponential. We have to capture scaling economics, and we don't always do that. But we don't always do that with many technologies, and that was a huge problem during the climate rush of 2018, 19, 20. One of the things I think about is that we're in a new era now. I call it demand to scale. You can have that, the first slide, please. Oh, I have to press this. Okay. Here's our first slide. From demand to scale. Well, lots of things have changed. We have an unprecedented demand for critical materials, but not only for critical materials, but for energy. We always have to think both in terms of critical materials as well as in terms of energy, because they're very much related. And what we're seeing these days is actually unprecedented. However, we're also seeing lots of bottlenecks. We're seeing too many legacy methods that are being applied, legacy methods that are not competitive. We're seeing too many mining practices that are ancient. Football field-sized tractors plundering the earth, disturbing biodiversity in a way that ultimately will be hugely harmful to humanity. Then we also have issues around the grid, many of the things that were talked about this morning. So what have we learned? Well, biology-enabled separation has worked. We've demonstrated that in the past 2 years. So 8 years to 2 years. We've demonstrated that we can capture rare earth elements using biology. We had not demonstrated that 2 years ago. We hadn't even thought about it, frankly. We started the company less than 2 years ago. In addition, we've found ways to apply synthetic biology to make fertilizer from scavenged methane. And for the past few years in a company called Codexis, we've been able to make protein from scavenged methane. So giant leaps forward. And I think we'll see them coming with increasing intensity. The question I keep asking myself is, as we learn how to scale in a capital efficient manner, what are the consequences for investors? Are digital assets still going to be superior? Or will there be a rotation in market caps? Will mining companies that still sell in less than 10 PE going to approach NVIDIA, 40, 50 PE? Huge leverage. That's huge leverage. And I think we're going to see a rotation from digital assets, software as a service and the like. And I think we're going to see atoms starting to eat bits. And your work will become more valuable because it's all about time. 20 years is too long. 20 years does not work for early stage investors. It has to be 10 years or less. And we can do that. Second, on the next slide, I just thought I'd share with you how we think about things in this environment. First, how does Mother Nature do it? Mother Nature is really good. But she's had billions of years, and she can make products that can be adapted and can be very valuable. We use one of those products to make fertilizer. We use one of those products for protein. So we always have to ask ourselves, does the technology leverage natural processes? Because we have two options in biology. We have the option of DNA-directed manufacture of proteins, or we can use enzymes that are available from Mother Nature. She provided them for us. I still always wonder why the enzymes involved in photosynthesis never were more than 1% efficient. Someday we're going to figure out how to fix that, and that's going to help us solve a lot of problems. Second, the masters of scale, China. They plundered us in solar, they plundered us in lithium-ion batteries, and there's more coming. So we must always be aware of what China is doing. Finally, China can build anything. China has a trained workforce to be able to build any electronic product. 70 million people. I would guess in the US there may be 2 million that can build multiplex different kinds of electronic products, from iPhones to computers, etc. So we have to be conscious, and we have to think about the compatibility of what we're doing with our free enterprise system. We've actually had some luck. In 2008, we started a company in China called C-Nano, which actually turned out to be very successful because we rode their coattails on knowing how to scale. And today we're making carbon nanotubes for a very, very low cost price. The third thing that's big for us is mission-oriented leadership. This is the biggest problem in every company we get involved in. Is there somebody in front of the company? Is there somebody leading the company who has a missionary sense of purpose about achieving the goal? And also understands the goal, the true north. What is the goal? It's absolutely critical to know where you're going. Because if you don't, as Yogi Berra said, you'll get there. Finally, the question we ask ourselves, especially during this past 2 years of incredible progress, does AI accelerate what we're trying to do? Can AI compress timelines? Time is money. And AI is an extraordinary technology. I never thought I'd see that in my life. And really purely a consequence of Moore's Law. Without Moore's Law, we couldn't do AI. So always think better, faster, cheaper. We can't sell products at premiums. There's no such thing as green premium. Mostly, I don't agree with our governor candidate in California who says there's absolutely no such thing as green premium. There is. We are gaining green premiums in our investments in building and construction. Building and construction accounts for 40% of GHG. We've been able to make some amazing investments in windows and substitute structural materials and in energy conservation materials. Again, part of the glory of materials revolution. One other comment I might make is the importance of behind the meter and the importance of obtaining new energy technologies and materials technologies, the application of material science to improving the fuel efficiency of data centers as well as the operating efficiency of data centers. Fiber optics, one example. Cooling, innovative cooling technologies. But on the other side, there's also the fuel efficiency aspect. Currently, energy costs account for 40% of the operation of the cost of a data center. It's too much. Integrated circuits are probably another 40%, and everything else is 30%. Energy costs are too high. SMR will never get cheap enough to be an effective behind-the-meter source. But we have identified other approaches using a combination of solar and hydrogen, for example, to get behind the meter at very, very low cost. So the march goes on, and I'm thrilled to be part of it. Thank you.